Good afternoon, everybody. Alright, I need to see over here. Once you're here, just say something in the chat. Are you ready to start? When are you ready? Make sure everything is good. Yes, Yanis, what is it? Yes, Victor. Alright, so as promised yesterday, we will be doing the transformations first. So let me get transformations out of the way. In order to be good at your transformations, you need to remember a couple things. You need to remember how to multiply matrices most importantly. That's the most important thing that you'll need to do. You'll learn how to multiply matrices together. So we will do a quick thing for just turn off all my notifications. We'll be doing some past papers as well. Right, so if you don't know how to multiply matrices, you're going to end up with no problems. Go and watch the videos I have for multiplication of matrices. So we are gonna spend too much time on it because I want to do some paper ones and paper twos as much as I possibly could. So transformations. First things first, we have four types. We have translation, which is a vertical or horizontal slide. I just taking something and I'm moving it about. There's no change in shape, no change in size. There are rotations, which are rotating something about a point. We have enlargements, which are called which fall under dilations, which can be either an enlargement or a reduction. And we have reflections, and each one is governed by some form of a matrix. So the first one, if I have a translation, my translation will be some vertical shift. So I will have the translation vector t plus the coordinates of the point A will give me A prime. So for example, if a point x, which is equal to, let's say 2, 6, is translated by a vector t, which is negative 1, 4. What are the coordinates of x prime? And this works for all points. I will have x, which is 2, 6, and the only thing we have to do is bring it in a column form. So instead of having 2 and 6 next to each other, I'll have 2 and 6 above and below. Same thing for the translation vector t, minus 1, 4 plus 2, 6 is equal to x prime and I just add each corresponding component. This is minus 1 plus 2, 4 plus 6. Minus 1 plus 2 is minus 1. No, minus 1 plus 2 is 1, sorry. And 4 and 6 is 10, which is equal to x prime, and just bring it back in a coordinate form, which is 1 comma 10. If I show you one, I'll show you all. 2. Let's do rotations first. Now, actually, before I go into rotations, for all the other transformations, we have a matrix kind of equation that we need to follow, and all of them follow the same rules for the matrix equation. So let me just get that matrix equation for you all here. It's very, very simple. So just give me 1 second. Right. So the matrix equation is A, B, C, D. A, B, C, D multiplied by an object point, x, y, will give me the image point, which is x prime, y prime, where A, B, C, D is the matrix that governs whatever transformation I am doing. So for example, rotations have a matrix that governs them. Reflections have a matrix that governs them. Dilations have a matrix that governs them. So we need to know each of these matrices. So for rotations, the matrix that governs rotations, the matrix responsible for a rotation about the center, about the point 0, 0 in a, I will want to say it's a clockwise, let me just double check that for you. Rotation in a counterclockwise. Direction is cosine theta, negative sine theta, sine theta, and cosine theta, where theta is my angle of rotation. So for example, let me say I have a shape, and the shape has vertices. I'll use a triangle. Most of them, the easiest way to see these things are with right angle triangles. So if A is a vertex of the triangle and A is 2, 2, B is another vertex of the triangle, and let's say this is 5, 2, and C is the last vertex of the triangle, and let's say this is 5, 7, are the vertices of a triangle. And is rotated about the origin. Now for rotations, don't really fight up too much with, so suppose I have a rotation that is not about the origin, don't fight up too much about that. I've never seen CXC brought a rotation that is not about the origin. It's rotated about the origin. Let me put it 90 degrees clockwise. What are the coordinates of the image A prime, B prime, and C prime? Now I just have to show you one calculation for these things here, and you will be able to do it. If I show you how to calculate rotations, the exact same procedure is used to calculate a rotation arm a reflection or a dilation or enlargement. It's just different matrices we will be using. So one time this one have a little variation in it. Matrix responsible for the rotation of body point 0, 0 in a counterclockwise direction, but the question gave me rotation in a clockwise direction. It's about the origin, so that is good. So if I rotate 90 degrees clockwise, I want to figure out my counterclockwise rotation. A counterclockwise rotation will be 270 degrees counterclockwise. Just take it away from 360. So first things first, 90 degrees clockwise is equal to 270 degrees counterclockwise. I'll just put CC for counterclockwise. The matrix is cosine theta, sine negative sine theta, cosine theta, and I have my angle of rotation. So I have cosine of 270, negative sine of 270, sine of 270, cosine of 270. So let me just load up the calculator here. I'll be jumping in my calculator. What is cosine of 270? Remember, your calculator have to be in degrees. Cosine of 270 is 0. So the first entry in my matrix will be 0. What is negative sine 270? Negative sine 270 degrees is 1. Sine of 270 degrees will be negative 1. I'm going to fix this bracket here. Negative 1. And cosine of 270 degrees is 0. So this is the matrix responsible for this particular rotation. All I need to do now is to go and calculate each image point. So for the first one, I'll have the matrix, which is ABCD, which is 0, 1, negative 1, 0. That will be our matrix responsible for my rotation. Multiplied by the object points, x, y, will give me my image points, x prime, y prime. So we have 0, 1, minus 1, 0, multiplied by, this is from A to A prime, multiplied by the point 2, 2, and like I said, go to my videos and you will see how to multiply these things very easily. This will be 0 by 2 plus 1 by 2, I'll get 2, minus 1 by 2 plus 0 by 2, I get A prime will be 2, negative 2, and convert this back to coordinate form. This is 2, negative 2, which is the coordinates of A prime. For B to B prime, I'll have the same rotation matrix 0, 1, minus 1, 0, but this time I'm multiplying by the matrix B, sorry, the point B, bring it in the column vector form, 0 by 5, 1 by 2, minus 1 by 5, 0 by 2, minus 5. And from C, oh shucks, bring it into coordinate form now, which is 2, negative 5, which is equal to B prime. And from C to C prime, I will have 0, 1, minus 1, 0, multiplied by 5, 7, is equal to 0 by 5 plus 1 by 7 is 7, minus 1 by 5, 0 by 7 is minus 5. This is 7 minus 5. This is the coordinates of C prime. So I calculate the coordinates of my my image points. Now let me see what's going on. So what's that? This is rotations. This is transformations. So we dealt with, you could go back in the video when it's done. We dealt with translations and we're dealing with rotations now. So I'm actually going to draw this diagram. So if we observe here, the triangle has coordinates 2, 2, and I like to illustrate these things here for you, everybody. And this is an app, GeoGebra. I highly recommend you go and download it. GeoGebra does not sponsor anything on this channel. The next point B is 5, 2, and the last point C is 5, 7. So we have the points there. So I can make this a little bigger now. I'm going to construct the triangle A, B, C. Now remember, this triangle, the question says it's rotated 90 degrees in a clockwise direction, and we determined that 90 degrees clockwise is the exact same thing as 270 degrees counterclockwise in order to compensate for our matrix, because our matrix, the rotation have to be a counterclockwise rotation about the origin. So let me insert the origin here, and again you have to play up with the app to really understand how to use it. I wouldn't recommend going and learning it tonight but this is an app for future use, right? It's used extensively in a lot of pure mathematics and applied mathematics if you want to dive into those things. So I'm going to rotate this shape about the origin 90 degrees clockwise. So I have rotation of this point about the origin 90 degrees in a clockwise direction. So you can see that clockwise goes this way. So pivoting the point on the origin, and I'm moving the triangle. The coordinates of A prime is 2 minus 2. Let's check and see if that's true. 2 minus 2. The coordinates of B prime is 2 minus 5. The coordinates of B prime is 2 minus 5. And the coordinates of C prime is 7 minus 5. 7 minus 5. So by graphically, we can calculate it. And by calculations, we can also calculate it. Now, like I said, if I show you one calculation, I show you all calculation. What I will do, I will give you all the matrices that are responsible for all the necessary transformations. So this is the matrix responsible for rotations, and I'll list all the rest that are responsible for every other transformation. So I have my transformation here. And this is the matrix that is responsible for it, and all of them will follow the equation. So remember, we have different types of transformations, so we are catering for all the common types. I don't want to dive into creating and understanding how that is, so we are going to dive into that. So the first set of transformations will deal with reflections. Reflections in part A. The x-axis. For a reflection in the x-axis, the matrix will be 1, 0, 0, minus 1. The equation will be 1, 0, 0, minus 1 multiplied by some object coordinate to give me my image coordinates. Part B, we have a reflection in the y-axis. A reflection in the y-axis will be determined by minus 1, 0, 0, 1. And these are things you can learn of. Minus 1, 0, 0, 1. By the object point, it will give me my image point. Right? It follows the same examples above. So if I have, let me just say, the same triangle is being reflected in the x-axis, then I will use this matrix instead of this matrix here. So my calculations will be a little bit different. Part C, same procedure, different numbers. This is a reflection in the line y is equal to x. I will have 0, 1, 1, 0. So the equation will be 0, 1, 1, 0 multiplied by my object point xy. This will give me my image point x prime, y prime. And the last common one is y is equal to negative x. And these are for reflections alone. Let me just extend these lines here. It will be 0, minus 1, minus 1, 0. And the equation will be 0, minus 1, minus 1, 0 multiplied by object point, and this will give me my image point. Now we have more types of transformations. These here are reflections. We have to deal, well, we dealt with rotations just now, so let's put rotations. This is number 2. rotations. The rotation, the matrix responsible is cosine theta, negative sine theta, and cosine theta. I'm not gonna bother to write the equation because I think everybody could develop the equation by now. And the last thing we have to do will be dilations, or dilations are either enlargements or reductions. A dilation, which is an enlargement or a reduction, and I want to do an example with this. Most likely we will get one from my past paper and we will do it one time. It will be, I think it's 0k k0. Let me just double check that with you guys. Just give me 1 second, right? I'm just double checking that here. Not that. Right, here it is. Reflection. I like to double check this, guys. So it will be K00K. I left wrong side. K00K. In this case, K is a scale factor. And again, I'm not gonna write down the equation because it's pretty self-explanatory. Now, what I will have one more thing to do in matrices. This is just a general breakdown. Combined transformations, and this is a question that comes every single year. Combined transformations. If an object undergoes two different transformations, for example, if I have an object A is first passing through, let's say, reflection first, I'm just making up, symbolized by a matrix R, I will get A prime. And then I pass A prime through a I don't want to use rotation. Let me say we pass it through an enlargement. E, and I'll get A double prime. Now to get the coordinates of A double prime, one way we can do it is say, okay, I'm going to use my knowledge of transformations with matrices. Reflection R, it could be in any one of these lines. I'm just making up. Let me say it's a reflection in the x-axis. I will multiply the matrix by my coordinates of the point to give me my image. So 1, 0, 0, minus 1 multiplied by the coordinates of A will give me A prime. Then I will take A prime, run it through the enlargement matrix. So I'll have the enlargement matrix multiplied by A prime, and I'll get A double prime. That's one way to do it. So I'll write that down. We can first have the calculations. To get A prime, then have the calculations to get A double prime. However, we can jump from A straight to A double prime by combining the matrices. But combining the matrices R and E in a specific order. And I'll give you all the arbitrary example that you'll see a lot. So if I have A going through the matrix P, I get A prime, and then A prime going through a matrix T to get A double prime. Remember, the matrix P and the matrix T are two by two matrices. From A straight to A double prime, I can have a combined matrix T P, where I multiply the matrix T by P, and I use that to go straight from A to A double prime. And we will do one example, and I'm 100% sure when we do the past papers, we will get another example just like it. Well, another question just like it. So let me just say, right, we already have one particular transformation, which is a rotation. So I'm continuing from rotations. I'm extending the example. If the previous, I don't even know how to write that, because look at me rewind the video and see. If the triangle ABC, well, it will be A prime, B prime, C prime, is reflected in the, let me put the y-axis. What are the coordinates of A double prime, B double prime, C double prime? We have ABC, we have A prime, B prime, C prime. We can get A double prime, B double prime, C double prime. The transformation is a reflection in the y-axis. So I'm going up. My reflection in the y-axis is -1, 0, 0, 1. Sorry. So from A prime to A double prime, I will have the reflection in the y-axis, which is -1, 0, 0, 1, multiplied by the coordinates of A prime, which we worked out to be 2, -2, 2, -2, and this will give me the coordinates of A double prime. -1 by 2, 0 by 2, so we get -2, 0 by 2, 1 by -2, we get -2, which is -2, -2, which is A double prime. From B prime to B double prime, again it's the rotation reflection in the y-axis multiplied by the coordinates of B prime. B prime is 2 minus 5. 2 minus 5. -2, bam 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 bam, -5. And this is equal to -2 minus 5, which is B double prime. And from C prime to C double prime, I have -1, 0, 0, 1 multiplied by 2, sorry, I need to get the coordinates of C prime. C prime I think was 5 minus 7, 7 minus 5, sorry. 7 minus 5. -1 by 7, 0 by 5, 0 by 7, 1 by -5. And this is C double prime. I mean, let me check it and see. If I check this here, remember, my first transformation was this rotation. And then I transformed this triangle. I reflected that in the y-axis. I'm going to reflect that in the y-axis. Reflect this fella here in the y-axis. This is what I will get. This should be my final image. So let's just check the coordinates and see if they are okay. A double prime is 2 minus 2. A double prime is 2 minus 2. B double prime is minus 2 minus 5. Minus 2 minus 5. And C double prime is minus 7 minus 5. Minus 7 minus 5. So by doing two sets of calculations, I obtained my coordinates of A double prime, B double prime, C double prime. Now, the red writing here tells me I can go straight from A to A double prime by combining the two matrices T followed by P. Now, if you realize my second transformation, where is it, right? Somewhere here. My second transformation is written first in my matrix multiplication, and my first transformation is written second in my matrix multiplication. So I'll write out this here. Or we had ABC was being rotated using the matrix 0, 1, minus 1, 0. 0, 1, minus 1, 0 to give me A prime, B prime, and C prime. And then this fella here was reflected to give me A double prime, B double prime, C double prime by the matrix minus 1, 0, 0, 1. If I go straight from A, B, C to A double prime, B double prime, C double prime, I need to multiply the two matrices, but the second matrix is written first in my multiplication. So the matrix that will govern this one step to go from object to final image will be my first matrix multiplied by my second matrix. You realize that this matrix is written first, and this matrix here is written second. So let's actually check it out and see. Again, for those of you all who need help with matrix multiplication, go back and look at the videos. It will help you. So row by column, first by first, second by second, I get 0 here. Right? I'm doing it in my head, but please go back on the video and do this on your own. So here now it will be 1, 2, first by first, second by second, I get minus 1. Here now, first by first, second by second, I get minus 1. And first by first, second by second, I get 0. So based on this now, this matrix should send me from A straight to A double prime. Let's just check one point and see. So from A to A double prime, I will have the matrix 0, minus 1, minus 1, 0 multiplied by the coordinates of A. And A, if I remember correctly, was 2, 2. 2, 2. This is equal to minus 2. U by U, U by U, and U by U, U by U, minus 2. Which is equal to minus 2, which is actually A double prime. And that is A double prime, minus 2, minus 2. So instead of working out two sets of calculations, I just have one matrix multiplication, and I have one calculation for each of the points. So please go and check over this here, do the calculation for B to B double prime, C to C double prime, and so on. Alright, I think it's time we start our past paper. I have all the past papers. So I ask another multiple choice first. Which year do you all want to do? I have past papers, paper 1s from 1999 all the way up to 2021 January, and 1981 all the way up to 2018 June. So tell me, which one all I want to do? whichever one all I want to do, we're looking it up right now. Hey, good afternoon, Matthias. Remember, it could have a little period where I will just be quiet waiting for it to respond. So just waiting for it to respond, I saw. It'll take a while for my voice to reach Olia, and then for Olia to type in the chat for it to reach me, and then for my voice to reach Olia again. So Talma, what we gonna do? Alright, Shane say 2018. I will look up 2018 one time. Alright, first come, first serve. Let me go with June 2018. Here, this is a good copy. So, let me go with June 2018. Past papers, maths, paper 1, June 2018. Alright, see a couple months say 2018. Alright. So we time and resolve. I want everybody to time on themselves. I'm just checking to see if I could see this clearly. So I put it up my stream to make sure I can see it clearly as well. If I maximize this, I want to know if to increase the size of these things now. Now man, all I should be able to read these the questions very smooth. Well, at least if you're on a desktop. I don't know about phone. I don't know if it's coming through clear to read on a phone. Alright. Time in resolve. 6:37. I should put a time on the side here. Alright. So timer. Stopwatch. Alright. So I will can pin the stopwatch there. I'll keep the stopwatch up on this side here. June 2018 for paper 2. I'm doing paper 1s. Alright, you can see clearly on the phone. Alright, cool. Alright, so we are starting. The number 3.14063 written correct to 3 decimal places is, so 1, 2, 3. I look at the fourth, it's more than 5. I add 1, so it's 3.141. What percentage of 40 is 8? So we have a formula, is over of multiplied by 100 over 1. The is 8, the of is 40, multiplied by 100 over 1. Bam bam, bam bam 2, 20%. Now remember, you again 1 mark for this, so you again marks for your working. Using the distributive property, 49 by 17 plus 49 by 3 is, we can factorize this, 49 into 17 plus 3, which is 49 by 20. A. The next term of the sequence is, this looks like a Fibonacci sequence, where, actually no, I just add 6 and 1 is 7. I add 7, then 13 plus 9, then 22 plus 11. So I'm just adding a sequence of even numbers. So I add 5, 7, 9, 11. Then I have to add 13, so I'll get 46. .45 written as a common fraction in its simplest form is, that is 45 over 100, which is 9 over 20. A certain amount of money is shared in the ratio 2 to 3 to 9. If the difference between the first and the second share is 40, then the amount of money shared is, so let's calculate how much is the total number of parts. So 2 to 3 to 9 is 2 and 3 is 5 and 9 is 14. So the difference between the first share, so the first share is 2 over 14 and the second share is 3 over 14. you say the difference is equal to $40. So 1 over 14 is $40. So 14 over 14 will be 40 multiplied by the 14. 14 by 40. And we get 6, 16, 1 for his form is 5, 560. Which of the following sets is equivalent? A, B, C, D. Equivalent sets have the same number of entries. So PQRS, self-explanatory. The shaded region represents, this is P complement, A, everything except P. In the Venn diagram, the number of students in each set is shown. How many students do not play volleyball? So right now, these students here play volleyball. 4 and 2 is 6. Alright? So 5 and 3, 5 students don't play volleyball, and 3 students don't play volleyball, so that is 8. No, sorry. Out of these students here, I'm going to make the diagram a little simpler. 2 people play volleyball only, and 3 people play hockey. This is hockey. Yeah, 3 people play hockey only. This here will tell me, actually no. Yeah, 8 is the answer. My bad. I'll stay. 8 is the answer. If Q is equal to ABC, how many subsets can be obtained from the set Q? So the number of subsets will be 2 to the power n, where n is the number of elements. This will give me how much subsets it have. So the number of elements here is 3. So 2 to the power 3 will give me how much subsets? So the answer is C. Number 11. Which of the following sets is empty? If P is prime, Q is odd, and R is even, P intersect R, prime and even. Yes, 2 is a prime number and 2 is an even number, so that is not empty. P union Q, that will not be empty. P intersect Q, no, still not empty. Q intersect R will be empty because one is odd, one is even. We have nothing in common with both of them. If P and Q are 2 sets, where the number of elements in P union Q is equal to 13, and the number of elements in P intersect Q is equal to 6, number of elements in P is 9, then the number of elements in Q is, let me think about this a second here. An easy thing to do here is to draw a diagram. We also have a formula. Here, we have a formula. The number of elements in P union Q is equal to the number of elements, oh good lord, the number of elements in P plus the number of elements in Q minus the number of elements in P intersect Q. If I make the number of elements of Q the subject of the formula, I send everything else on the next side. So I'm just going to put numbers here. P union Q is 13. Number of elements in P is 9. I don't know what the number of elements in Q is. Take away P intersect Q is 6. Send everything across. 13, take away 9, plus 6 is the number of elements in Q. 13 minus 9 is 4. 4 and 6 is 10. 6 is 10. A man's taxable income is 20,000. He pays tax at the rate of 28%. The amount of income tax he pays is, so he pays 28% of the 20,000. So 28 over 100 multiplied by 20, 1, 2, 3 over 1. I'm not even going to bother to do my multiplications. 28 by 2 is 56. So the only thing that has 56 in it is C. So I'm going to multiply the whole thing. A man's basic wage for a 40-hour week is $160. He is paid $5 per hour for overtime. If he works 6.5 hours overtime in a certain week, his wage, so we just had to multiply 6.5 by 5. So 6.5 multiplied by 5. If you want to convert it to a decimal, you could go ahead and do so. Improper fractions could work just as well. So it's 13 over 2 multiplied by 5. 13 by 5 is 65 over 2. This could be 3, 34.5, like $34.50 overtime.
So I have to add this to his 160 plus 160.00, 50 cents, 49, 194.50. Shucks, 32, my bad. 2 into 5 is 32. Right, so this here is 192.50. My mistake. Number 15. If $6 is equivalent to 1 US, okay? So 6 TT is 1 US. Then 15 TT, I want to know how much 1 TT is. 1 TT is 1 over 6 US. So 15 TT is 1 over 6 multiplied by 15. That will be 15 over 6. 6 into 15 is 2. That is 12, 13, 14, 15. We made a 3 over 6. That is 2.5. Like $2.50. The annual interest rate on a 15-year mortgage on a house assessed at a value of $450,000 is 5 cents on every $1. Let me read that again. The annual interest rate on a 15-year mortgage on a house assessed at a value of $450,000 is 5 cents every $1. What is the interest rate paid on the mortgage for the first year? So for the first year, I need to figure out how much dollars I have in 450,000, and I have how much 5 cents I have in 450,000. So it will be 450,123 divided by 5 cents, and 5 cents is 0.05 of a dollar. Move you. So we get 0, 0. 5 into 45 is 9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So on every dollar, let me think about this for a second. Assessed at a value of $450,000. 5 cents. Yeah. 5 to the 45 is 9. We don't have to minus it. We just want to know the interest paid. 5 cents on every dollar. Oh, we have to multiply it. You have to multiply it. It'll be 450,000 multiplied by 5 cents, which is 0.05. So I just write in 45 by 5 and I add in normal zeros. 5 5s are 25, 5 4s are 20, 22. This is 2, 2, 5. And how much zeros I have? I have 1, 2, 3, 4 zeros. And I must have 2 decimal places. So $22,500. B. Mary invested $200 for 5 years. Here with me, I see a response. Thanks. Mary invested $200 for 5 years at 5% per year. John invested $500 at the same rate. If they both receive the same money, the same amount of money, simple interest, for how much years did John invest? Alright. So Mary, principal by rate by time over 100. Bam, 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 5 to the 10. Mary got $50 interest. John get the same interest. We want to know how much years John invested in. So John, we have principal by rate by time over 100. Well, simple interest is that. Right, sorry for the small writing. If I rearrange to get time, I get simple interest multiplied by 100 over principal by rate will give me time. 50 multiplied by 100, because both of them got the same simple interest at the end, over John invested $500 at the same rate. 500 at the same rate, which is 5%. You go with you, you go with you. 5 into 50 is 10, and 5 into 10 is 2. So 2 years. A salesman sells a car for $1,100. If he is paid a commission of 4.5% for the first 10,000 and a 7.5% on the remainder, then the commission he receives is, so he first $10,000, he got 4.5%. So we're calculating the 4.5% multiplied by the 11,000. No, multiplied by 10,000, sorry. Bam, 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 bam. 4.5 by 100, 1, 2, he get $450 a day. He still have $1,000 left. So he got 7.5% on that. Of the remaining 1,000, bam, 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 he got $75 a day. When you add up them two numbers, we get 5, we get 2, we get 5. $525. A television set costs $30. $350 cash when bought on hire purchase. How much money is saved by paying cash? Alright, so let me calculate the hire purchase price. It will be the down payment, $35, plus the 12 monthly installments of $30 each. This is 35 plus 12 trees are 360. That is 3 and 3, 6 and 1 is no. $395 a higher purchase, and if it's $350 cash, that's a $45 difference. So you're saving a $45 if you buy it cash. Mr. Jones bought a car for $64,000. The car depreciates by 20% in the first year and 10% in each of the following years. The value of the car at the end of the second year was. So the car depreciates by 20%, meaning it's 20%. The value of the car is worth 20% less than it was at the beginning of the year. So 64,000 multiplied by 20%, multiplied by 20 over 100, bam, 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 bam. That is 64 by 2, 6 2s are 12, 128, 0, 0. Right, 12,800 is how much it depreciated by. Take it away from the 64,000. We get 0, 0, 4, 3, 1, 2. 3 minus 2 is 1. 6 minus 1 is 51,200 was the value of the car at the end of the first year. It depreciated by 10% in the year after that. So I'm calculating 10% of the 51,200. Bam, 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 bam. That is 5120, and I'm taking it away from 51,200. Take away 5120. 0 to 1 8 0 5 4 1 6 46080 46080 C. Alright, so a nice little question here. Number 21. I'm going to show you a shortcut for number 21, so please just pay attention to your little shortcut. Not too bright. 21. We have 1 over 5x plus 2 over 3x. If I have two fractions and I'm either adding them or multiplying them, I will multiply this way, multiply this way, and multiply this way. I'll give you all another example after. If I multiply this way, I'll get 1 by 3x is 3x. I multiply the next way, I'll get 5x by 2 is 10x. And I multiply the two denominators by each other, I get 15x squared. The top becomes 13x over 15x squared. I just cancel the x with the x squared and I get x. So 13 over 15x. D. Let me just give you our next example here. A over b plus x over y. I multiply this way, that is ay. Multiply this way, That is bx. I'll keep the sign in the middle. If it's a minus, leave it as a minus. And I'll multiply this way, by. So if I have a third plus a half, I'll multiply this way, 1 by 2 is 2. Multiply this way, 3 by 1 is 3. Multiply this way, 3 2 is 6. That's 5 over 6. And you can check it on the calculator if you want to. Same thing for subtracting. Then this only works for two fractions. I don't care what the numerator is, I don't care what the denominator is. This works for any two fractions. If that is equal to that, then x is equal to, just a rearranging. One time I'll expand in the brackets. I get 10x take away 5 is equal to 35. Move the 5 across, I get 30. So 10x is equal to 30. X is 30 over 10, which is 3. See. That by that is, this is 3 2s are 6, x squared and x cubed. When the bases are the same and we are multiplying, we must add the powers. So 2 plus 3 is 5. So the 6x to the power 5. 3 star 6 is 12. Okay, so 3 star 6 is equal to 12. And then 2 star 5 is equal to 9. Then A star B may be defined as, alright, so in cases like this, I will recommend just check each one of the questions, each one of the answers. So if A, and I just writing this down, all I do have to write this down. If A star B, and I'm just assuming it's equal to 4 into B minus A, then 3 star 6 will be 4 into 6 minus 3. 4 into 3, and I get 12, and I'll check it for 2 star 5. Then 2 star 5 is equal to 4 into 5 minus 2. 5 minus 2 is 3. And 4 3s are 12. So I know that this one is wrong. If A star B is equal to, and I'm assuming it's equal to A squared minus B, then 3 star 6 is equal to 3 squared minus 6. That is 9 minus 6, that is 3. So one time this is wrong, because 3 star 6 is supposed to be 12. Using the answer for B, 3 star 6 is 3. If A star B, and I'm assuming it's C now, 6A take away B, then 3 star 6 will be 6 into 3 take away 6. 18 take away 6 is 12. And then 2 star 5 is equal to 6 into 2 take away 5. 6 2s are 12. 12 minus 5 is 7. So again, 2 star 5 is supposed to be 9. So the answer can only be D. And we can also check it over and see. So if A star B is equal to 2A plus B, then 3 star 6 is 2 into 3 plus 6. 6 and 6 is 12. And 2 star 5 is 2 into 2 plus 5. 2 2s are 4 and 5 is 9. So 2 star 5 is 9. 3 star 6 is 12, which corresponds to 2A plus B. Somebody saying 22 wrong. Supposed to add 5. Oh shoot. How luck say? 44. My bad. Alright. Good looking out with me. Number 25. When 8 is subtracted from a certain number, so let me call the number x. So 8 take away some number x, and this result is multiplied by 3. The answer is 21. What is the original number? 24 minus 3x is equal to 21. Move the 21, move the 3x. 24 minus 21 is 3x. 3 is equal to 3x, and x is equal to 1. Cool. X is minus 2, y is 3, and t is 2. Okay. X over y to the power t. X is minus 2. Y is 3 and t is 2. Anything to be squared is positive, and this follows laws of indices. Square the top, square the bottom, I get 4 over 9. What is the order of the matrix Q? Alright, so the order of the matrix Q, everything in matrices is row by column. I have 1 row, 2 row, 3 rows, and I have 1, 2, 3, 4 columns. So this is a 3 by 4 matrix A. The determinant of P is the leading diagonal. Again, if you need help on this, check the videos. The determinant of P would be the product of the leading diagonal, which is 8 by 5. Take away the product of the other diagonal, which is 7 by 6. 8 by 5 is 40. Take away 7 6s, what is that? 42 minus 2. Minus 2. So I thought 25 is 15. 25, right? No? Think about it. 15 take away 8 is what? 7. 7 3s are 21. How did I get this here? Let me see now. 1, 8 is subtracted from 1. Oh, 8 is subtracted from a number. Sorry, this is supposed to be x minus 8. Sorry. So we have 3x minus 24 is equal to 21. So 3x is 21 plus 24. 3x is 2 and 2 is 4, 45, and x is 15. Sorry about that, guys. D. If the vectors p and q are so by so and so by so respectively, p minus 2q is, so p 3 2 take away 2q, which is minus 1 4, and distribute the 2 inside. I will get 3 2 take away, it will be plus now, right? You just have to be very careful with these things, right? Plus minus 2 by that is 2, and minus 2 by that is minus 8. 3 and 2 is 5, and 8, 2 minus 8 is minus 6. So 5 minus 4 by 2 is 8. Yeah. I'm expanding it out a little better than this, right? So this will be 3 take away 2 into minus 1, and 2 take away 2 into 4. This is 3 plus 2 is 5. 2 take away 8 is, yeah, minus 6. Oh, the first one had the minus 6. Cool. The T. Parallelogram R is the midpoint of XY. Okay. ZR, that is this here, from Z to R, these vectors. The common point is Y. So ZR, or they give us a set of options here. Okay. So let me check and see. I check in A. ZR is WX. Good lord. Actually, I'm gonna work it out here, right? ZR is ZY plus YR. ZY and WX are the same thing because they are parallel. They are the same vector. And YR is a half YX. YR is also negative a half of XY. So we can have WX minus a half XY. So WX, right, this is WX minus a half WZ Yeah, that can work. Yeah, xy is the same as wz. I'm just checking the second one. So far, A looks like the correct answer. B, a half wc, no. Wx plus 1 half wz, no. And no. So A is the answer. Alright, the following refers to which of the statement is true about the perimeter of the square and the rectangle. We can actually calculate the perimeter. The perimeter of the square will be 48. The perimeter of A is 48, and the perimeter of B is 16 plus 16. I like to write it out for multiple choice. Plus 9 plus 9. 16 and 16 is 32. Plus 18. 3 and 1 is 4. And 1 is 5. So that is 50. So 50. So the perimeter of A is less than the perimeter of B. D. I think it's C. I'll only assume it's for this one here. Wx plus a half wz. Wx plus 1 half wz. No, your direction is important. The vector doesn't go so. The vector is going so for ZR. So it wouldn't be in the same direction. Three to the 800 expressed in meters. So millimeters to meters. If you want to do your conversion, from millimeters to centimeters. 10 centimeters. Sorry, 1 centimeter is 10 millimeters. So 1 meter is 100 centimeters. So 100 centimeters is actually 1,000 millimeters. So 1 meter is 1,000 millimeters. So we want to know how much to the 800 millimeters is. Just divide by 1,000 and we get 3.8. B. XY is the same as WZ. Alright, watch this here, right? ZR is ZY plus YR. The direction is important. ZY plus YR. Now, YR is a half YX. Or you can say YR is negative a half XY because of the direction. Alright, so I see a say never mind, I get it. The distance around the edge of a circular pond is 88. The radius in meters is, so circumference is 2 pi r. So 88 is equal to 2 pi r. 88 over 2 pi is equal to r. Bam bam, 44. Oh, we have it here, 88 over 2 pi. Cool. Refers to the following, which shows a triangle and a square. The length of one side of the square is 5 and the height of the triangle is 4. What's the total area of the figure in centimeters squared? Right, so the area of the square is 25 and a half base by perpendicular height. So it could be a half 5 by 4, which is a half of 20, which is 10. So the answer is 35. In the volume in centimeter cube of a cube edge 3 by 3 by 3 is 27. Volume is side cube. The area of a rectangle is 53.6. Aha, I did a question like this a while ago. This is a nice question. The area of a rectangle is 53.6. If the length is multiplied by 4 and the width is halved, then the area would be, so I want to illustrate this here. I think I have this in a past paper. Alright, we wouldn't dive into that. I'll see if I could remember how to do over this proof. I can't remember the exact answer for the proof, so we go just develop the proof here. So the area of a rectangle, length by width. They say that if the length, the area here is length by width. If the length is multiplied by 4, so A2, if the length is multiplied by 4 and the width is halved, then the area will be 4L multiplied by a half W. So A2 will be twice length by width. So if I have one area and then I have a next area where the length is being multiplied by 4 and the half is being doubled, then the area is also being doubled. So if it has 53.6, the area is doubled. C will be my answer. So from A1 is equal to length by width. A2 is equal to 2, twice the length by the width. If I increase the length by 4 and the width by 2, we can test it, you know. We can test it. Let me test it and see. I think it's half. I don't think it's double. Let me see this dimensions here is 10 by 20. The area here is 200. If I take the same rectangle and I increase the length is 20, right? Now the longer side. The length is multiplied by 4. So the length 20 by 4 is 80. And the width is halved. So this could be 5. Then the area of this here could be 5 by, that is 400. Cool. So the area is doubled from A1 to A2. So A1 to A2, the area is really doubled. On leaving Trinidad, the time on a pilot's watch is 2300 hours. As soon as you see this, draw your clock. 23, oh good lord, that's not a good clock at all. 2300 hours is, this is 12, this is 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 24. 12. So 2300 hours is 11 o'clock in the night. Arrived in his destination in the same time zone on the next day, which shows 300 hours. So 300 hours is 3 o'clock in the morning. So we traveled 1 hour, 2 hours, 3 hours, 4 hours. Area of a trapezium is half the sum of the parallel sides multiplied by the perpendicular distance between them. 18 and 8 is 26. Half of 26 is 13. 13 by 5 is 65. What is the modal age? Modal is most frequent. So 7 years is the modal age. How many children took part in the survey? Just add them up. Number of children is 3 and 4 is 7, 8, 9, 10, 11, 12, 13, 14, 15. The median of the numbers is cancel first with last, first with last, first with last, first with last. 6 and 7, in the middle of that is 6.5. When 3 coins are tossed simultaneously, the possible outcomes are tra-la-la-la-la. What is the possibility of randomly obtaining at least 2 heads? So at least 2 heads is a minimum of 2 heads. So they actually listed out all the possible outcomes. So the total number of possible outcomes is 1, 2, 3, 4, 5, 6, 7, 8. So it'll be something over 8. How much times will I get at least 2 heads? Well, 1, 2, 3, 4, 4. 4 out of 8, which is a half. 600 students write an exam. The probability of a randomly selected student failing the exam is 1/5. How many students are expected to pass? 4/5 of them are expected to pass. So 4/5 of 600. 5 into 60 is 12. That is 480. 480 are expected to pass. The interquartile range of the lengths of fish is, so let me see. Well, lengths in meters of 20 fish caught by 2 fishermen. The interquartile range is Q3 take away Q1. So Q3 will be 3/4 of the 20. So 3/4 of 20 is 15. And Q1 is 1/4 of 20, which is 5. So 5 will correspond to, what is that? That looking like 1 point something there. This is 1.5, 1.1, I'll say 1.2. So Q1 is 1.2. 15 going across, dropping it here, going down, that looking like, zooming in a little bit here, right? Right, so that looking like 5, 13, 3.7. This is 3.7, and when I take away both of them, I get 2.5. Right, that's my interquartile range. Which of the following best illustrates a function? A function is a relation that has one output. So I see this one here, I have one to many, so this is not one here. I have a one to many here, so this is not one here. This is a one to many, this is not one here, this is one to one, so this is the answer. The equation of the line which passes through the point that has a gradient of 4 is 0, 5 is a point on the y-axis, so this is actually the y-intercept. So y is equal to 4x plus 5. See? The graph of the inequality in the diagram, x is less than 1. It's an open circle in the less than direction, so x is less than 1. The gradient of AB in the graph above is, you can either use the formula y2 minus y1 over x2 minus x1, or you can use rise over run. So the rise here is, what is that? 2, and the run is 1, 2, 3, 4. 2 over 4, which is a half. And the gradient is in this direction, so it's positive half. F of x then f of minus 3 is, it'll be 2 into minus 3 squared minus 1. 2 into 9, minus 1, 18 minus 1, 17. The maximum point is 2, 4. That was an easy one. What is the gradient of the straight line? Bring it in the form y is mx plus c. So I'll have to divide by 2 throughout, minus 3x minus 8. So y is equal to minus 3 over 2x minus 4, minus 3 over 2. Which of the following best describes the function? So from 2 to 5, it looked like multiplying by 2 and I added 1. 5 to 8, I am not multiplying by 2 and I added 1. That will be x plus 3. 8 to 11, I add in 3. 11 to 14, I add in 3. So y is equal to x plus 3. Yeah. If each interior angle of a regular polygon is 60 degrees, then the polygon is a, I think that's a hexagon. Yeah, it'll be a hexagon. I forget the formula. Does anyone remember the formula for this here? I know that the total number of degrees in a shape is n 180 into n minus 2. Yeah, into n minus 2, where n is the number of sides. Where n is the number of sides. This will give me the total number of degrees in a shape. We could test it for a triangle. N is 3. 118 to 3 minus 2 is 118 to 1. Make it 180 degrees. Check a square. It's just for you to check. There is another formula. I can't remember the formula. With interior angles. If anybody remembers it, please put it in chat now for everybody else. In the diagram, A, B, and CD are parallel. Which of the following best describes the relation between x and y? They are equal. This is alternate angles. The value of x is, that is 30 and 30 is 60. 180 minus 60 is 120. 25 was an easy one. The image of a point P on the... look, we got a translation here. So, remember, for translations, it is the object point, which will be P, plus the translation vector will give me P prime. So, P is minus 2, 3, plus the translation vector is 3, 4, will give me P prime. Minus 2 plus 3 is 1, 4 plus 3 is 7. Change it back to coordinate form, 1, 7. Alright, look at another transformation question here. In the diagram above, the line CD is the image of AB after that looking like a straightforward reflection in the y-axis. Yeah. 58. Right, this is similar triangles. The area of ABC, if the area of ABC is 20 centimeters squared, right, what is the area of MNO in centimeters squared? Right, so one is bigger than the other. So what we can do, it have two ways we can do this, and I'll show you all the easier way to do it. If the area of ABC is 20, then the length of BC will be 20 is equal to a half base by perpendicular height, 6 by the height, h. So 20 is equal to 3h. And the height is 20 divided by 3. Half of 6 is 3. Area of ABC is 20 centimeters squared. This is equal to my height. This fella here is half of this fella here. So the length, my height here, will be half of 20 over 3. So half of 20 over 3 is actually 10 over 3. So this is my height ON. And 10 over 3, the area of OMN, the smaller one, will be a half base by perpendicular height. The 3's cancel. Half of 10 is 5. I know that there's also a formula. The area of A over the area of B is equal to K squared, but K is the scale factor. Well, we don't have a scale factor here, so actually we had a scale factor. We could have calculated, which is 2. Straight lines. Oh, look at enlargement here. Now, this is very important with enlargements, and I wanted to do a question with enlargements. Enlargements, the scale factor could either be positive or negative. Depending on the sign in front of the scale factor, the position of the image changes. For example, if a scale factor is positive, both the object and the image are on the same side of the center of enlargement. If the scale factor is negative, then both object and image are on separate sides of the center of enlargement. And I'll illustrate it on GeoGebra in a little while. What is the scale factor for the enlargement? Both object and image are on the same side, and the image is bigger than the object, which means my scale factor is supposed to be greater than 1, and it needs to be positive. So the answer is C. The diagram, okay, trigs, bam, 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 bam. Alternate angles, U is 30, U is 60. the height of YZ in meters. If I use any 30 degrees, this is opposite, this is adjacent. So I'll have tan of 30 is equal to opposite, which is YZ, over adjacent, which is 10. So 10 tan 30 is equal to YZ. Let's see if that's one of the answers. 10 tan 30. Another way we could have done it is by using the 60-degree angle, and I'll just do it in a different color. If I use in the 60 degrees, then this fella will be my opposite, and this fella will be my adjacent. I will still be using tan, but I will have tan of 60 is equal to opposite over adjacent, YZ. So YZ would have been 10 over tan 60, but it just so happens we do have 10 over tan 60 in the answers. And that's it. It took 47 minutes to do that exam, with a little time we spent on some explanations. So I'll say about 2 minutes we spent on explanations. So for an exam that took us, supposed to take us an hour and a half, we do it in 45 minutes. So we had what, half an hour remaining again? Yeah. Cool. Alright. So that is one paper done. Which paper 2 you all want to do? Are waiting or listening? Yeah, paper 2, which one? Are we waiting? And for all the newcomers, please consider subscribing so you'll get notified whenever we go live to do any little worksheet or any little class we decide to have. Please. Right, I have time to do piece of a paper 2. Right, I have time to probably do just section 1 of a paper 2. What I can do, I could just leave out number 1, number 2 one thing. Nah, that was 2018 paper 1 for June. For paper 2, I have January up to 2021, and I have June up to 2019. So just give me a sec. Alright, everybody. Be back. ASEAN Men's January. Alright, no scene. I have no problem with that. January 2021. We could just jump that in here. Insert. I do think it's a good copy I have, you know. Paper 2's January 21. It's not the best of a copy, but I mean, we will work with what we have. Alright, so in the essence of time, I will not do some questions that are too easy. Wait, a long document, bro. Nice. Cool, so we're in the game here. Right? Number 1A, part 1, all you could do that. Part B, all you could do that as well. Insulate the wall, exact thickness of the insulation. Alright, this is areas and stuff. All you're supposed to be able to do this. For an exchange, all you could do that. Factorization. All you're supposed to. Anybody have a better copy of 2021? Just asking. If anybody has a better copy of 2021, I will listen it to me. You could send it to me if anybody have it. Please, please, please. Find quality in this little. It's workable, but if you could get a better one. Alright, thank you very much. Alright, so give me a sec. Let me just go and download this and put it here. Alright, guys, just Bear with me a couple of seconds. I'm trying to get a good copy of 2021. Alright, my bad. I forget my microphone is muted. I'll go in and start over. Hardlocks. Alright, so a little bit of tips before you all write your exam. First thing I want all you to do is to read your instructions. Make sure you fill out your name, write your registration number, everything clearly. Make sure you have everything there. Next, read through your instructions. I don't know how the structure of the exam is coming this year. I don't know if you're getting like in this one, section 1 has 7 questions. I don't know how much questions coming in section 1. I don't know how much sections coming in section 2, and so on. So read your instructions carefully. Show all you're working. If you require extra paper, you're supposed to get extra paper with the booklet. If you need more paper, then you can always request for more paper. every time you start a question, let me see. If you're doing your working on a piece of paper, number your questions with your working, please. Please, please, please number your questions with your working. Show your working neatly. Very neatly, please. What other pieces of art? You have a formula sheet. You get a formula sheet here. The formula sheets remain the same throughout all the past papers. So you have a lot of formulas here in the formula sheet. You actually have your sine rule and your cosine rule. I think you have your quadratic formula. Yes, you have a quadratic formula. You have your trig ratios. You have all your formulas for the area of a triangle. You have areas, volumes. You can go through the formula and them on your own. Before you start your exam, take a couple minutes. Go through all the questions. If you know you are strong with the question one, which usually are the same thing every time, you have your addition of fractions, you have little indices, you have your little decimal places and stuff, please, please, please do those questions if you're comfortable with it. It makes no sense you sit down and you read a question and you don't know where to start. If you don't know where to start when you read a question, by all means, jump to the next question one time. Don't waste time. Do the questions that you can't do first. Then come back and organize the questions that you will get in trouble with. My advice, if you don't know where to start, write down what you know with respect to that particular question. So let's just say, right? Let's just say for part B, the thickness of one sheet of cardboard is given as 485 by 10 to the minus 2 millimeters. So that's the thickness of a sheet of cardboard. A construction worker uses 75 sheets of the cardboard stacked together to insulate a wall. So he takes sheets of cardboard. So let me say all these are sheets of cardboard. He takes sheets of cardboard and he stacks them together. Show that the exact thickness of the insulation is so by so. Well, this here is just a multiplication of thicknesses. Write the thickness to two significant figures. So this was a real easy question, right? But the wording of the question might intimidate some students. Please do not let no question make you feel small. If anybody have any questions, go ahead and ask it in the chat. I will address them as I see them. And let me start with these things here. So I was saying that I will just run through the questions that I know will give a little bit of problems. So number 1, A and B, easy peasy lemon squeezy. Part C, foreign exchange, easy. 2 part A, factorization, it should be easy, but 2 part B, looking a little not nice. So we could do 2 part B. Show that x over 1 minus x take away 4x is equal to this monstrosity on the next side A. Now remember the shortcut I showed you just now. This here is 2 fractions. One fraction is x over 1 minus x take away 4x over 1. Straightforward proof. Remember, we cross multiply this way, so 1 by x is x. Keep the sign in the middle. Cross multiply this way, that is 4x multiplied by 1 minus x, all over, and multiply this way now. 1 minus x multiplied by 1. Expand it up. I get x take away 4x plus 4x squared all over 1 minus x. X minus 4x is minus 3x plus 4x squared over 1 minus x. I just put in the 4x in the front. 4x squared minus 3x over 1 minus x. Factorize the x. X into 4x minus 3 all over 1 minus x, which is exactly what I want. Hence, solve this equation. Well, if I have this fella here is equal to 0, we just now prove that this fella here that I circled is actually x into 4x minus 3 all over 1 minus x. So if I have x over 1 minus x minus 4x is equal to 0, that is the exact same thing as saying x into 4x minus 3 over 1 minus x is equal to 0. Cross multiply, I get x into 4x minus 3 is 0. I get x is equal to 0, or 4x minus 3 is 0. Move the 3 across, divide by 4, x is 3/4. Make v the subject of the formula. V right now is trapped inside of a square root, so I'll square both sides to get rid of it. So I'll square, let me put it on the next side here, right? P is equal to the square root of 5 plus vt. I will square both sides. So P is equal to, well, P squared is 5 plus vt. Move the 5 across. P squared minus 5 is equal to vt. Divide by t. P squared minus 5 over t is equal to v. The distance needed to stop a car D varies directly as the square of the speed s at which the car is traveling. A car traveling at a speed of 70 kilometers per hour requires a distance of 40 meters to make it stop. This is variation. So we have the distance needed to stop a car D is directly proportional to s. Get rid of the directly proportional sign by putting an equal sign and introducing a constant k. We say where k is a constant. So they give us a condition: a car traveling at a speed of 70 kilometers per hour requires a distance of 40. So d is equal to 40 meters when s is equal to 70 kilometers per hour. Studying to change that into kilometers, you know. And let me see what we get here. So 40 is equal to 70 k. Yeah, I think I need to change that to, I need to change the distance to kilometers. 40 meters is 40 divided by 1000, 1, 2, 3, that is 0.4 kilometers. So 0.4 is equal to 70k. 0.4 over 70 is equal to k, s squared. Oh shucks, oh, good looks, s squared. So I need to square the speed now. 70 squared. Jump on the calculator. 0.4 divided by 70 squared. No, I think we have to leave it as 40 divided by square of the speed. 2 over 245 is directly proportional as the square of the speed which it is traveling. 0.04, 1 to 0.4. I'm just checking something here, right? Divided by 70 squared. Nah, I don't think that's it. To me, I want to change it. 1 to 3.04. Yes, that's right. 0.04 divided by 70 squared. Still, that's a big fraction. To change that day by, let me just check. To me, I want to change it. Yeah, I would have liked to change it. Alright, so seeing it wasn't changed, so I'll leave it in still want to change it, right? We will leave it in meters. 40, so 40 over 70 squared is equal to K. I'll leave that like that. So I could rewrite my formula now and say that D is equal to K 40 over 70 squared S squared. So they say what distance is required to stop a car traveling at 80 kilometers per hour. So D is equal to 40 over 70 squared multiplied by 80 squared. Divided by 70 squared multiplied by 80 squared. 552.244. Did they say any decimal places? No. 52.244 correct to 2 decimal places. In the diagram below shows a grid tra-la-la. Pentagon P is something to pentagon Q. Pentagon P is congruent. So congruent means same shape, same size, doesn't matter the orientation. And I say that same shape, same size, it doesn't matter the orientation. Next, the diagram below, not drawn to scale, shows a pentagon, the VWXYZ. In the pentagon, YZ, okay, YZ, parallel to XW, okay, and YX is parallel to VW, okay. Angle XYZ is 114 degrees, XYZ, while angle VZY is 90. VZY is 90. Part 1. Determine the value of WXY. So WXY will be this here. So WXY, he looking like a little corresponding angles. If I extend this line here, you could say let the diagram be so by so. Take your ruler and extend this line, please, everybody. Extend your line here. Call this angle theta. You can say that 180 degrees is 114 degrees plus theta, and your state angles in a straight line sum to 180 degrees. So theta is 180, take away 114, 56. 180, take away 114, 66. Good. Angle, okay. Oh, well, it will still be 66 degrees. Say that this is angle alpha. You say theta is alpha because corresponding angles are equal. Angle ZVW. ZVW, that is this angle here. We could call this angle anything we want. Let me call it beta. U is that, U is that, U is that. Yeah. Same thing again. I can extend this line here. Bam shot. Calculate the size of this angle here. Let me call this angle little x. I could say little x is equal to 180 degrees take away alpha. That is 180 take away 66, and that is 114 degrees. I don't need to put back a reasoning why, because I already state angles in a straight line sum to 180 degrees. Now there's a formula that I just now show earlier, where the total angles in any polygon is given by the total sum of angles is 180 into n minus 2, where n is the number of sides. In this case, the number of sides is 1, 2, 3, 4, 5. 5 minus 2, which is 3. So 180 into 3, that is 480 degrees, is the total number of angles in this shape. So I can say that how 114 interior angles, okay, plus 98 plus beta, we will call this fella here y, because why not, and this is also equal to y. And again, I'm not going to state corresponding angles are equal because we just stated that. Y was 114 plus alpha was 66, supposed to be equal to 480 degrees. Rearrange, calculate for beta, and we will get beta is equal to, we'll check it out, 114 plus 98 plus 98 plus 114 plus 66 is that 480, 88 degrees. Easy peasy double. Oh, shit. Yeah. U is 114, so U is 114, U is 66. Yeah, 148. Cool. And I get 88. Let me just double check that again. I think I make a mistake. I don't think I make a mistake. Let me just check it out on my calculator here. 114 plus 98 plus 114 plus 66, take away 480, 180 by 3, oh, 540, Jesus Christ. Well, 16 by 3 is 48, this is 540 here, sorry guys. Right, my little bit mistake on my calculation. So you see, even I just make my little mistakes. 148 degrees. That is why I always use a calculator. Alright, my mistake. Alright, so transformations. Enlargement by a scale factor of 2 about the center C, 6, 6. Okay, now because we didn't have enough time to run through this here, I didn't have time to run through it earlier, I will just do the solutions. You might understand what's going on, you might not understand what's going on, but I'm going to do this over in GeoGebra. So draw this in GeoGebra, boy. Yeah, go draw it in GeoGebra. Alright, so just give me 2 seconds. Let me see how best I can draw this in GeoGebra. Clear all, don't save. Show grid, show axis, good. So let me say that is 3, 2. 4, 4. 5, 2. 5, 2. And the center of rotation is 6, 6. And I can probably join that line there. Cool. So let me construct my little lines here now for you. bam, bam, bam. Right, 3 point. Okay, I think this could be the line here. So I'm gonna just again I join it over in GeoGebra, right? 3.5 comma 3 and 4.5 comma 3. Bam, bam. Okay, I'm going to just hide all the labels so you can see the shape what's going on, and I'm going to explain what's going on here on GeoGebra, and I want it to just follow it, right? Okay. Oh Jesus. Alright, so this is the shape we're dealing with here. We have the axes and stuff. We're good to go so far. The enlargement of the letter A by a scale factor of 2 about the center 6, 6. Now, an enlargement with scale factor 2 means that the shape is increased by 2. A scale factor of 2, it's double the size. How do we do this? First, we take the ruler, we measure the distance from the vertices or the important points. We measure the distance from the important points to the center of enlargement. So in this case, it will be from the top of the A to the center of enlargement. I'm taking my ruler and I'm measuring that distance. If that distance is 4, the distance of the image will be twice that. So the distance of the image will be 8 in the same direction. So if I, again GeoGebra, if I measure this distance here, I get that. Right now, on your, actually, draw accurately each of the following transformation and enlargement by scale factor to about the center 6, 6. You can use the matrices to do this. You don't have to go through the calculation on the graph. Alright, so we're gonna do that. Oh God, Jesus. Alright, so observe this here, right? If we recall, we did transformations just now, and transformations that underwent a scale factor, in this case is an enlargement, is k0, 0, k. K is scale factor. So if I label the vertices here A, B, C, then from A to A prime, it will be k0, 0k multiplied by the coordinates of A, which is 4, 4, and it will give me A prime. Scale factor is 2, so this goes to 2 and 2. So 2 by 4, 0 by 4, we get 8, 8. On the diagram, 8, 8. You don't have enough space on the diagram to draw this. Oh, this is with center of origin 0. Okay, we can't use the calculation. Sorry. The calculation, the calculation depends on the center of enlargement being 0, 0. We had it right. So let me jump back into GeoGebra here. So we draw the distance here, measure the distance, bam, bam. We get the distance. We get the distance. Now we know that how the scale factor is 2. That means that from the center of enlargement to the image point, it will be double the distance as the center of enlargement to the object point. So if this here, now on your ruler you wouldn't get this exact thing, you will probably get 2.8. So if I multiply this by 2, I will get 5.6, and so. But I mean, the up is very, very accurate. So what I will do, I will just enlarge it one time, dilate. Okay, I need to put the shape. Dilate u, about u, scale factor of 2. Then I dilate in u, about u, scale factor of 2. Dilate u, about u, scale factor of 2. U, about u, scale factor of 2. And u, about u, scale factor of 2. So again, I am doing this here, and then I'm going to show what we're going on, right? So from here to here, then from here to here, then from here to here. Cool. So what's going on here? The lower one is my enlargement. Now, I'm going to measure the distances and show you what. When you measure with your ruler again, you're not going to get the level of accuracy I will get on the up. I'm measuring the distance from image point to center of enlargement. I get 2.82. Now I'm going to measure the distance from the, that is object point to center of enlargement. Now I'm going to measure the distance from the image point to the center of enlargement, and it will be double the distance from object point to center of enlargement. This will happen for each of the vertices. So when you're doing questions like this, especially for enlargements, make sure that if it's a scale factor of 3, this distance here, and I'll draw it on the, this distance here, I'm multiplying that by 3 along the same line to get my image point. This distance here, I join it along the same line to get my image point 3 times, if the scale factor was 3. In this case, the scale factor is 2. So watch. Bam. And if you watch, it's along the same line. From D to here, it will be along the same line as from D to the image point. From D to here, it will be the same line as D to the image point. From D to here, it will be the same line from D to the image point. And lastly, from D to here, it will be the same line from D to the image point. They follow the same line. Alright, yeah, diagram looking a little confusing now with all these lines, but don't fight up yourself. If I could hide all these things here. Yeah, I could hide all these things. Good. Cool. Alright, so on the graph paper, that is what you have to do. Make sure that the length of the lines is just twice the amount, 3 times the amount, 4 times the amount, half the amount, depending on the scale factor. A translation of the letter A using the vector t, which is negative 3, 2. Now for each of these points here, you'll have to perform your translation calculation, where you have the object point, well, the translation plus the object point, that will give me my image points. So for example, minus 3, 2 executed on, let's say, the point A on top, which is 4, 4. This will give me minus 3 plus 4 is 1, and 2 plus 4 is 6. So I'll go to 1, 6. This is from A to A prime. From B to B prime, I will have the same translation vector, minus 3, 2, plus the coordinates of B, which is 3, 2. Minus 3 plus 3 is 0, and 2 plus 2 is 4. That will be the point B prime under the translation. Do this with each of the points and enjoy your image. The function f is defined as, so the diagram below shows the mapping diagram, determine the value of a. So a is the first one. So 3x minus 2. This means when I take an input of 1, I get an output of a. When I take an input of 0, I get an output of 3 using this formula here. So when I take an input of 1, I will get 3, take away 2 into 1, I get an output of a. So 3 minus 2 is equal to a. A is equal to 1. Determine the inverse of the function. So if f of x is equal to 3 minus 2x, we let y be equal to 3 minus 2x. Then we interchange x and y. So I'll get x is equal to 3, take away 2y, and then I solve for y. So I move the 2y, I move the x, I get 2y is equal to 3 minus x. So y is equal to 3 minus x over 2. And finally, let f inverse of x be equal to 3 minus x all over 2. The composite function f squared x. Now f squared x is f of x. And know what f of x is. This is f of 3 minus 2x. This means wherever I see x, I put in 3 minus 2x. 3 minus 2 into 3 minus 2x. 3 minus 3 to the 6 plus 4x minus 3 plus 4x. If you can trouble with this, go back in yesterday's video and look through to where we did functions. State the value of f inverse of negative 2. First, I'm going to calculate what f inverse of negative 2. I'm going to calculate what f inverse of negative 2 is. That's 3 minus 2 over 2. 3 plus 2 over 2. 5 over 2. So this becomes f of 5 over 2, which is equal to 3 minus 2 into 5 over 2. 2's cancel. 3 minus 5 is minus 2. Using a ruler, draw the lines x is equal to a half. Right, so I'm not going to draw it here, I'm just going to tell you what it is. X is equal to half, that's a vertical line passing through the point 1/2. So it will be here, and it will be this vertical line here. Y is equal to x. Y is equal to x will pass through the points 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. And x plus y is equal to 5. Just substitute the x value, or just which two x and y values will give me 5? 2 and 3. 2, 3. There's a point. Where again? 1, 4. There's a point. So this here will be your line, x plus y is equal to 5. On the grid label, x is greater than a half will be this direction here. Y is greater than or equal to x. You test a point. I'll pick any point above. This here, I'm picking a point. I'll pick the point 2, 3. 2, 3, y is greater than that, so that will be above here. And lastly, x plus y is less than 5, so I'm picking a point here. 1 plus 3 is less than 5, so this is below here. So I'll draw this in GeoGebra as well, so you all will see what actually going on. It might be confusing, but I mean, all are supposed to know this. X is greater than or equal to a half. That's all the points to the right of that. Next, y is greater than or equal to x. Write all the points above that line. Finally, x plus y is less than or equal to 5. That will be above. So let's see this little triangle here. That is what they're looking for. They're looking for the shaded triangle here. I should have asked you something. Oh yeah, they didn't. Okay, so there's the region R. The shaded piece of the triangle with vertices. We have no the vertices. So we're gonna bother. Alright. 60 students took an algebra test which comprised of 15 multiple choice questions. The number of correct answers that each student obtained is recorded in the table below. So the number of correct answers and the number of students. Using the table, determine the number of students who had exactly 13 correct answers. Right? 11 students had 13 correct answers. The modal number of correct answers, so it's the most frequent. So 14 students had 9 correct answers, so 9 is the modal number of correct answers. The median number of correct answers. Median will be the middle. So to calculate the median in this case here, you all can just assemble these numbers in ascending or descending order, and then cancel first with last, first with last, first with last, first with last, and that's it. Right, I don't have much time again here. The probability that a student chosen at random had at least 12 correct answers. So the probability that a student had at least 12 correct answers is the probability that the student, probability that x is less than or equal to 12. So how much students had less than, at least 12? I think at least 12 means he had more than 12. So how much students had more than 12 answers correct? It will be 11, well, 2 plus 11 plus 9 plus 10, follow it, man. 2 plus 11 plus 9 plus 10 all over 60. Let me just check and see what the next one is here. Right, pie chart, easy peasy lemon squeezy. Right, now I wish I could have done the whole paper, fellas and ladies, but I have other commitments. So I will give all you a couple minutes to ask me any questions all you want. I will post a link in the chat here for you all to get past paper solutions for all the years, paper 2s. So you all can go through the past paper solutions if you all want to. Right, I'm sure plenty of you all know about this website, fastpassmaths.com. So go ahead, click on that link. It have solutions from ever since for all paper 2s. If anybody have any questions, right, this is my number, 7934754. Don't call me, message me. If I am waking, I will assist. If I sleeping, I'm not going to assist. Right? Yeah. So again, I'm waiting if anybody have any questions.
Yesterday we did bearings questions, Kyle. You could go through the questions from yesterday for bearings. The one example that I did yesterday, it was a very good example. It touched on all the different types of angles you could get. Like I said, most of the time it will be a corresponding angle that you'll have to develop with all your knot lines. I sent a link in the chat yesterday for a past paper, not a past paper, sorry, a worksheet for bearings. I'll send back the link for the worksheet. It has answers as well in it. I wouldn't have enough time to go over bearings. Were you here yesterday for the bearings class? This is it. Yes, that's the same concept, Shane. It's the exact same concept. It's just drawing a line. That is all. You draw a line. It's supposed to be good in coordinate geometry. When you draw a line, your graph is now separated in two pieces, above the line and below the line. All you have to do is test a point in either section to see if it satisfies the inequality. Remember, a point consists of two coordinates, so you can just test it and see. For example, if I give you an example here, delete, delete, delete. If I have a line 2y is equal to 3x plus 4. This line separates the graph into two parts, above and below. I want to know which part is 2y less than. I'm looking at less than. Okay? Test a point. The easiest point to test for every single one is 0, 0. Unless the line passes through the point 0, 0. But the concept is the same. At the point 0, 0, my x coordinate is 0 and my y coordinate is also 0. I'm going to substitute my x into the equation and my y into the equation, and I will get, look at the equation, 2y is equal to 3x plus 4. If I bring it down a little bit, you can probably see it here better. Y is 0, so I get 0. 3x, that is 0, so I get 0 is 0 less than or equal to 4. Yes, it is. So when I have a less than sign here, underneath the graph is satisfied. If I have a greater than sign there, above the graph is satisfied. So if I change this inequality here to a less than sign, you'll see underneath the graph will be shaded. Two y is less than or equal to 3x plus 4. Write it over. 2y is less than or equal to 3x plus 4. Nice. Under the graph is shaded. I mean, I have the notes on all of these things, but it's just to understand what the notes say, because there's notes, they don't have an explanation behind them. And like I say, I just come on here to help out there. I don't want to teach over anything because it could take way too long to teach over full topics. All you should have be paying attention to all the teacher during the term. Okay, if anyone has any further questions, feel free to message me on WhatsApp. I'm not taking no calls. If you call me, I'm going to block you. No problems are here. What I want all of you to do, just take all the time and take the advice that I gave you all before. Read through your exam. See which questions you can do. Do those questions. The website I sent, the FastPass Maths, that has solutions for all past paper 2s. Go through them. If you fail to prepare, prepare to fail. Please don't spend whole night
trying to learn off things in mathematics, it might not end well for you. To know maths, you have to do maths. I want to wish everybody here the best of luck in their exams. Best of luck in your exams. After the exam, once I get a copy of the exam, I am going to do it tomorrow. As long as I get a copy of the paper 1 and the paper 2, tomorrow evening we're going to do the solutions on YouTube. So if anybody gets a copy, please send it to me. And we will do the solutions and we will see where mistakes were made or if mistakes were made. What else? Yeah, that's it. So good luck to everybody. Take your time, do your questions, and hopefully I'll see you guys tomorrow. Tomorrow as well, I will be doing the review in AdMaths. We have a little more time before the AdMaths exam, so at least we could get some more questions out of the way for AdMaths. Please don't wait until night before to come and ask me to teach all a whole topic. I'm not going to do that. I'm just here to help all you do questions. No problem, Geraldine. Yes, Kyle, I'll be doing art maths from tomorrow. If I do get the paper 2 and the paper 1 from maths, I'm starting the same thing for art maths from tomorrow. And every day until the exam, until the night before the exam. Alright guys, it was nice. We will do it twice. We here tomorrow, we here next day until AdMaths done. And then I can take a 5 and actually enjoy my vacation. So again, good luck to everyone. Say your prayers. Take your time. Pass all the exam. Later.